Absolute value is another concept that we're going to cover that also includes the number line. We've done negative and positive integers, order of operations. What we're going to talk about right now is the absolute value of an integer. We know that integers less than 0 are negative, more than 0 are positive, and 0 is neither positive nor negative. The absolute value of an integer is how far is that number from 0 on the number line. So we use two vertical bars to represent absolute value. So the symbol for absolute value of 3 is a 3 with two long bars on each side of it. The absolute value of 3 is 3 because that number is 3 units away from 0 on the number line. So here's positive 3 on the number line, and it is 1, 2, 3 hops away from 0. Okay, so the absolute value of it is 3 hops from 0. Now the same is true of negative 3. Down here on the negative end, it is also 1, 2, 3 hops away from 0. So its value is also positive 3. Absolute value just means how far away from 0 is this number. Now the absolute value bars act like parentheses when we're doing order of operations, and I'll show you a little bit about that next. Looking at some of these practice absolute value problems. The absolute value of negative 25 is 25 because negative 25 is 25 units away from 0 on the number line. Looking at the next problem, however, we don't just have a single number inside the absolute value brackets. We have negative 10 minus 28. Now, while we're solving this problem, we're going to continue to bring down the brackets just as if we had these in parentheses. So when I'm solving this, I have negative 10 and add the opposite of 28, which is negative 28. So I have negative 10 plus negative 28. Now I have the absolute value of negative 38. Remember, when we have two negatives, we add those groups together. And the absolute value of negative 38 is positive 38. For this example, we have 34 plus negative 17 inside of absolute value brackets. So we're going to use our order of operations to solve what's inside the absolute value brackets. That gives us the absolute value of 34 positives and 17 negatives. We have more positives than negatives, and we have 17 more positives than negatives. So the absolute value of 17 is 17. When we get down to our second row and we're looking at absolute value of a number with the negative on the outside of the absolute value bracket, we're going to solve what's inside first and bring down the negative sign. So bringing this down, the absolute value of 16 is 16, and then we pull our negative down in front. So negative 16 is the answer to that one. The absolute value of 14 is 14. The negative absolute value of negative 18. So the absolute value of negative 18 is 18, and pull that negative down to make it negative 18. It's as if there was a negative sign on the outside of parentheses here when we're doing this. Alright, we also need to look at how to compare absolute values. You're going to compare absolute values pretty much the same way you would any other number, but you're going to solve the absolute value first before you compare it. So we have negative 18 and negative 11. Negative 18 and negative 11 are here and here on the number line. Now remember, the farther left you go, this is less down here, and this is greater. Up on this end. Okay, so you have less on one end, greater on the other end. So negative 18 is less than negative 11. And so our small end of our less than sign goes towards the negative 18. Now in the next problem we have the absolute value of negative 37 and the absolute value of 37. The absolute value of negative 37 is 37. Negative 37 is 37 units away from 0. Positive 37, that absolute value is also 37 units away from 0. And so these two numbers are equal. I'll let you fill in the 21 and absolute value of negative 11 on your own. Okay. Temperature-wise, when we're looking at lowest recorded temperature, and I believe this is supposed to have a negative in front of it over here, compare negative 81 and negative 9. Negative 9 is the lowest recorded temperature in Australia, and negative 81 is the lowest recorded temperature in North America. I want you to go ahead and do this one on your own. Here are a few that have expressions that we're evaluating. And when we're evaluating expressions, we're going to substitute a number for a letter. For example, in this first one, we have 2b, the absolute value of 2b minus 6. Okay, when we have a number and a letter right next to each other, that means multiply. So what we have here is the absolute value of 2 times b minus 6. Now the value of b is negative 4, so I can substitute that into my expression. The absolute value of 2 times negative 4 minus 6. 2 times negative 4 is negative 8. So now we have the absolute value of negative 8 minus 6. The absolute value of negative 8 is 8 minus 6, and that answer is 2. Setting up the next one, we have 8 times the absolute value of w. Now w is negative 6. So this becomes 8, and because these are right next to each other without a sign in between, that's multiply. 8 times the absolute value, and w is negative 6. So 8 times the absolute value of negative 6, and I'll let you answer that one. And then go ahead and answer the last example on your own also. We have several word problems that are left here. Suppose a and b are integers and the absolute value of a is larger than or greater than the absolute value of b. Must a be greater than b? Okay? Now, it's not asking if the absolute value of a must be greater than the absolute value of b. Must the variable a be worth a number that's greater than the value of variable b if the absolute value of a is greater than the absolute value of b? Use examples to support your answer. So write out some hypothetical equations where to support what you're saying, if it does or if it does not have to be greater. Do decimals have excuse me, opposites? Explain. Okay, for what values of x does the absolute value of x equal negative x? Then you've got some problems to simplify also. Okay, you're going to complete the rest of these on your own for this part of your homework. We'll go over these answers in class.